Okay, what we're going to look at in this tutorial is how to solve a trig equation using Pythagorean identities, and this is without a doubt the most fun you are going to have all day. Now, let's take a look at this first example. We're going to look at two examples. We're going to take a look at this one first, and then we're going to hop over to this one once we get done with this tangent squared equation. So what we want to do when we're solving a trig equation is we want to first identify how many trig functions do we have in the problem. In this particular case, I have two trig functions. I have tangent squared, and I also have secant. And that's not good for us. We don't want to see multiple trig functions. Sometimes we can work through the problem with factoring and factoring out a trig function and handle it that way. But in this particular case, we are not going to be able to solve this equation with a tangent and a secant in the problem. And this is why we've learned Pythagorean identities. Because what we're going to be able to do is we're going to be able to take this tangent squared here, and we're going to be able to use an identity to rewrite this portion of the equation. So we should know that tangent squared is equal to secant squared x minus 1. So what that's going to allow us to do is rewrite the left-hand side. I'm basically just doing substitution here. I'm going to take tangent squared out, and in its place, I'm going to write in secant squared x minus 1. I'm not going to do anything to the right-hand side. I'm just going to leave it as it is, which is 1 minus secant x. Okay? So now I'm in a position where I only see one trig function. I see secant squared on the left, I see secant on the right, and I'm going to get everything over to one side at this point. Basically, I want to look at this as a quadratic equation from Algebra 2, for example. I'm just going to get everything to one side and set it equal to 0 and try to factor it or use another strategy. So that's exactly what I'm going to do. I'm going to add over secant. So secant squared x, again, I'm going to add secant, which makes it plus secant. I'm going to subtract 1, which gives me negative 2 on the left. Okay, so once again, all I did is I subtracted 1 from both sides. I canceled the 1's out here, and I added secant. And I wrote it the way I did because I want it to look like a trinomial, like I said, from Algebra 1, Algebra 2. Okay, so I'm going to go off to the side here. If this doesn't look familiar to you, well then think about this. If I gave you something like x squared plus x minus 2 equals 0, how would you factor something like that? And hopefully we can look at this and see, oh, all right, that would be x plus 2 and x minus 1. That's exactly what I'm going to do in green here. But now it's just going to be a secant x instead of just an x. So it's going to be secant x plus 2 and secant x minus 1. So again, the factoring isn't different than what we've learned how to do previously. As always, if I come back over to the purple here, I would set my factors equal to 0. So my answers here would be x equals negative 2 and 1. No different on the left side. I'm going to get secant equals negative 2 and positive 1. Okay, now if we were solving the purple equation, I would be done here. Unfortunately, when we're solving trig equations, we have one more thing we have to do. Now we go to the unit circle and we figure out where is secant negative 2 and where is secant 1. Now, I always like to rewrite these. Anytime I'm doing reciprocal functions, I'd like to turn them back into sine and cosine. So I'm going to turn negative 2 into negative 1/2. Now, when I flip 1, I still have 1. I like to think of sine and cosine as opposed to secant and cosecant. So that's why I've rewritten that. You don't have to do that, but I think that helps. Now, since I was solving on the interval 0 to 2 pi, I have to go around the unit circle and figure out where is the cosine negative 1/2, where is the cosine positive 1. Hopefully we know the unit circle pretty well, but in case you don't remember the unit circle very well, let me take a minute and bring that up real quick. All right, let's grab the unit circle. Okay, so here's a picture of the unit circle. Again, hopefully this is something that you already feel comfortable with. So I want to know, where is cosine negative 1/2? So I remember cosine is x. So cosine, the x value is negative 1/2 here and here. And my radian measures at those 2 points are 2 pi over 3 and 4 pi over 3. And cosine is positive 1 at, I'm going to go back to here, cosine is positive 1 right here at 0. So my three answers in this case are 2 pi over 3, 4 pi over 3, and 0. Okay, so to recap what we just did there, since we had a mismatch, we had tangent and secant, I had to use an identity to rewrite it so that I only saw one trig function, and then I set it equals 0, factored, solved it from there, and went to the unit circle to figure out where those particular places were on the circle. All right, let's take a look at another one that's very, very similar, and that is this one right here. So once again, I have a mismatch. I have cosine squared and I have sine. Similar to the last one, the question is, which one can I use an identity on? I can't use an identity on sine x because it's not squared, so that's not going to work for me. But since the cosine is being squared, I can use an identity there. And we know that cosine squared is the same as 1 minus sine squared. So I'm taking out cosine squared and I'm putting in 1 minus sine squared. Now I've got a lot of cleaning up to do. I'm going to have to bring everything over to one side, but before I do that, I'm going to have to do a little distribution, combining like terms, all that kind of stuff. So let's go ahead and do that. I'm going to get 2 minus 2 plus 2 sine squared. Now hopefully we can see right now as I finish this out that those 2's are going to cancel up at the front. So I'm going to go ahead and get rid of those. So this 2 cancels with this 2. I'm going to swing both of these over to the left. Okay, and that's going to leave me with 2 sine squared minus sine minus 1 equals 0. Now this one's a little harder to factor. You know, the one we did a minute ago, the leading coefficient was 1. Those are always easier to factor. So this one's going to be a little bit harder, but I always like to use guess and check. So I'm going to go ahead and get my binomials set up. And I know that 2 multiples of 2 are going to be 2 and 1. Sorry about that, Bell. So 2 and 1. Now, I need 2 multiples of negative 1. Now, this is guess and check, so I don't know where the negative 1 should go. So I'm going to put the negative 1 here, and I'm going to put the positive 1 here. Now, I'm going to check it. So the quick check to see if I factor that right is I'm going to do outsides and insides. The outsides give me negative 2 sine. The insides give me positive 1 sine. If I add those together, I get negative 1 sine. Perfect. So that means I factored it right. Again, that's guess and check. There's other strategies, but I always like to use guess and check. All right, now that we have it factored, set the factors equal to 0. So sine x equals negative 1/2. And positive 1. So to finish up, just like on the last one, now we go to the unit circle. Where is sine negative 1/2 and where is sine positive 1? I know that sine is negative 1/2 at 7 pi over 6 and 11 pi over 6. And I know that sine is positive 1 at the top of the unit circle, which is pi over 2. So once again, I have 3 answers. We're not always going to have 3. We might have 4. We might only have 2. We might only have 1. You know, there's going to be a variety of different number of solutions. So that'll just depend on the problem itself. So let's back up to what we've been doing here. Look to see if there's a mismatch first. If there's a mismatch in trig functions, then ask yourself, can I use a Pythagorean identity? If you can, go ahead and substitute that in so that you only see one trig function in the problem, and then use skills that you've learned previously. Factoring. Maybe you don't have to factor. Maybe you can just use the square root method. There's all kinds of techniques that you might need to use at that point. But the key is using the identity at first to get the problem set up so there's only one trig function in the problem. Okay, hope that helps. Good luck to you on those.